Okay, so today we are continuing with sequences and series. We will recall that the last time we were talking about this topic, we covered this aspect, the aspect of sequences. So we dealt with this part of sequences. There we spoke about arithmetic sequences. We said that an arithmetic sequence is a sequence whereby there's a common first difference. And then we also spoke about quadratic sequences. Quadratic sequences are those sequences whereby there is a second common difference. Okay. And then we spoke about geometric sequences whereby there is a common ratio. Okay. Spoke about this. But then today we are doing something different. We are working with algebraic series. Okay. Algebraic series. Okay. And as you can see here that we have two types of algebraic series. We have arithmetic series, which I'm going to talk about now, and then we also have geometric series, which I will cover in a later session. So let's talk about arithmetic series real quickly. Okay, so we we spoke extensively on these kind of situations. By the way, this is an arithmetic sequence, all right? So this is an arithmetic sequence. Now, the question becomes, what is the difference between an arithmetic sequence and an arithmetic series? Okay, okay, this is a arithmetic series. So in an arithmetic series, what we are basically trying to do is we are taking all the terms that are present in an arithmetic sequence and then we are summing them or we are adding them together. Okay, so that is what we are doing in an arithmetic series. So this is still term one, this is still term two, and then this is still term three. Okay, so the sum of the terms. For example, this series has three terms. So if I'm trying to determine the sum, I will say sum 3 because the series has three terms. And then because of that, I will say 3 plus 6 plus 9. And this can be evaluated very easily because 3 plus 6 is 9 and 9 plus 9 is 18. Okay, so our sum is equal to 18 in this particular case. Okay, but then what if we are looking for sum 100 or sum 1,000 for that matter? It will not be practical for us to expand the series and write 100 terms or 1,000 terms and then try to add all of those terms together. That will take that will take forever. So what do we need to be able to solve these two problems is we need to come up with a formula that will enable us to easily evaluate or to easily determine the sum of the first 1,000 terms, the sum of the first million terms for that matter. So let us come up or let us develop a formula that will help us to win in these kind of situations. Okay, so in order for us to do this, we have to consider a general case. Okay, so Sn is equal to the first term, which is a plus a plus d. D is the common difference. and then the third term will be a plus 2d. All right, and then let me consider the last term. So the last term, I'll call the last term L. Okay, and then the second last term, it should be L minus D. Okay, and then this should be L minus 2D. Okay, so this is T1, T2, T3, and then this is the last term. This is Tn, this is Tn minus 1, and this is Tn minus 2. Hopefully you are asking the question that where does all of this come from? I'm hoping that you are asking that question. So let's briefly talk about that very quickly. You will you will remember that when we were talking about arithmetic sequences or arithmetic patterns, we said that T1 is denoted or it's represented by the letter A. And remember that the difference between T1 and T2 is the constant difference, and that difference is represented by D. Okay, so it means that T2 is A plus D, all right? And then T3 is A plus 2D, okay? So this is T2, this is T3, and so forth and so forth. And then remember that our last term, uh, we denoted that like this. We denoted that like this. So our last term is Tn, and Tn simply the L, and then the second last term is L minus D, because still the difference between the one term and the following term is that constant difference D, okay? And then this is L minus 2D, and so forth and so forth. So this is T n minus 1, and then this is T n minus 2, right? Hopefully this is making sense. And remember, what I said initially is that the difference between a series, which is this guy, and a sequence, which is this guy, is that in a series, we are taking whatever that is happening here in a sequence, and then we are just adding all the terms together. So if you can see that the only difference is that we have addition signs instead of semicolons, addition signs instead of semicolons, just to indicate that right now we are dealing with an arithmetic series instead of a sequence. Okay, hopefully you understand that. So let us continue with our derivation. We just remove this. Yay. Ah, my technology is not cooperating. Okay, so this is us adding the first n terms of an arithmetic sequence to obtain an arithmetic series. Okay, so this is equation number one. Okay, you agree with me that equation number one can also be written like this. I can say L plus L minus D plus L minus 2D, okay? And then I can say A plus 2D, and then I can say A plus D, and then I can say A like this. Let me just remove the brackets. Then I can say A, and then I can say this is equation number 2. Okay. Why am I allowed to do this? Remember that we are adding a bunch of terms. So A plus B is the same as B plus A. So equation 1 is actually the same as equation 2. It's just that whatever that I started with in equation 1, I ended with it in equation 2. Okay. So it's the same thing really. Okay. And then what we will do now is that we'll add equation 1 and equation 2. So Sn plus Sn will give us 2Sn, 2Sn, and then A plus L will give us A plus L. Okay. Thus, this plus this will give us A plus L because positive D will cancel with negative D. Hopefully you can see that. Okay. So we will have A plus L. The same thing will happen here because 2D, positive 2D will cancel with negative 2D, and then we will be left with A plus L still. Okay, so this will be A plus L. The same will happen here. I will have A plus L, and then the same will happen over here as well. I will have A plus L, and then the same will happen over there. A plus L is just A plus L. A plus L. Okay, so this is equation 1 plus equation 2. Okay, so we have 2 times Sn, and this is equal to what? Now we we have to understand that here we have a bunch of A plus L's, right? So we have to take note of this, okay? So this is the first one, okay? I would call it T1 because I obtained it by adding T1 and the first term in the second equation. And then let me call this one T2, T3. This one, let me call it Tn, Tn minus 1, and then I can call this Tn minus 2. So essentially what I've done is, or what I have is, I have A plus L's. How many A plus L's do I have? I have n A plus L's. Let me repeat. I have a situation whereby I have A plus L, A plus L, A plus L, A plus L, A plus L. But then I have to recognize that they are n A plus L's. So I can rewrite all of this by saying n times A plus L. Hopefully that makes sense. Okay, so this simplifies the whole thing. And then initially I was looking for Sn. So what I will do is I will make Sn the subject of my formula by dividing by 2 on both sides. So I will have Sn is equal to n over 2 A plus L. Okay, so this is our equation that we will use to determine the sum of any number of terms, provided that the series we are working with is an arithmetic series. Okay, provided that the series is an arithmetic series, we will use this equation to determine the sum of that particular series. Now, a few things to take note before we continue. So we know that A is the first term, T1, and L in this situation is the last term. and the last term is Tn. Okay, so we are able to use this particular equation. Now, what if we do not know the value of the last term? Then what happens? What if we do not know the value of the last term? The last term. Okay. What if we don't know the value of the last term? What then do we do in that particular situation? So we have to recall that Tn, which is our last term, has a formula, and we established that formula when we were working with arithmetic sequences. I mean, we said that Tn is equal to a plus n minus 1 multiplied by d. Okay, so if we do not know the value of the last term, instead of writing L, we will put this expression for L. Okay, we will put this expression instead of putting L in that particular equation. So now our Sn equation will be n over 2. We have a. Instead of writing L, I will write a plus n minus 1 times d. And then I'll do that, and then I can simplify the situation. I can have n over 2, and then a plus a is 2a plus n minus 1 multiplied by d. Okay, so this is the equation that we used to determine the sum if the last term or the value of the last term is not known. So we know that a is the value of the first term. This is T1. Okay, this is just the constant first difference that we spoke about. So this is the first difference, and that's all we need basically to determine Sn. And obviously the number of terms that we are adding, that will be the n. If they wants the sum of the first 100 terms, then n is 100. If they want the sum of the first 1,000 terms, then n is 1,000. Okay, so this is the equation that we use when we want to evaluate a arithmetic series. Okay, arithmetic series. So let's put this equation into practice. Remember, when we started, we started with an example. So we had the plus 6 plus 9. So this is our arithmetic series that we are working with. All right. So in this particular situation, we know that this is T1, this is T2, and then this is T3. Now, my question is, we determine the sum of the first 1,000 terms. This is what we want, and we have our equation. So it's n over 2 first term plus the last term. Okay, and now the question becomes, do we know the value of T1000 in this particular series? The answer is no, we do not know it. So because we do not know the value of the last term, we have to use this version of the equation. So we can say 2a plus n minus 1 times d. Okay, and then from here we can do our thing. So n is equal to 1,000. A is the first term. Our first term in this particular situation is 3. So basically, this is what we are talking about. T1, it is equal to 3. Okay, so 2 times T1, which is 3, and then we have n is 1,000, so 1,000 minus 1, and D, now D is the common difference, so we know that we obtain the common difference by saying T2 minus T1, so it will be 6 minus 3, which will give us 3, okay, so that will give us 3, and we can just insert all of this in our calculators and then see what we obtain from it. Let's see. 1,000 divided by 2 multiplied by the answer that we get is this answer 541 500. Okay, so this is the answer that we